Welcome. Today we learn about Introduction to Polymers and their classification. This lecture covers the complete technical content for plastics engineering students. Watch till the end. Then subscribe for more lectures like this. Today we learn about Introduction to Polymers and their classification. This is a fundamental concept in plastics engineering with wide industrial applications. We will cover principles, processes, and real-world examples in this lecture. The fundamental concepts of Introduction to Polymers and their classification start with precise definitions and terminology. Understanding the scientific basis helps us predict material and process behavior accurately. Standard units ensure consistent measurement across all industrial applications. Classification of Introduction to Polymers and their classification is based on structural differences and performance properties. Each type has distinct advantages that determine its suitability for specific applications. Knowing these differences is essential for correct material or process selection. The properties of Introduction to Polymers and their classification span mechanical, thermal, and chemical domains. Tensile strength, heat deflection temperature, and chemical resistance are the most important parameters. These values directly determine service life and product quality. The manufacturing process for Introduction to Polymers and their classification begins with raw material preparation and conditioning. Precise control of temperature, pressure, and time at each step is critical for quality. Quality checkpoints at each stage prevent defects and ensure consistency. The equipment used in Introduction to Polymers and their classification consists of a main processing unit, drive system, and control instrumentation. Each component performs a specific function that contributes to the overall process efficiency. Safety interlocks and sensors protect operators and ensure consistent product quality. Design calculations for Introduction to Polymers and their classification require applying fundamental formulas with correct parameter values. A worked example clarifies how to substitute known values and solve for the required quantity. Always apply a safety factor of 1.5 to 3.0 as per applicable engineering standards. Introduction to Polymers and their classification is applied across packaging, automotive, and construction sectors worldwide. In packaging, it provides lightweight, barrier-rich solutions at low-cost. Automotive and aerospace applications demand high strength-to-weight ratio and thermal stability. Quality standards for Introduction to Polymers and their classification are defined by ISO and ASTM specifications. Testing methods cover tensile strength, impact resistance, and thermal performance. Acceptance criteria set the minimum performance thresholds for commercial products. Environmental considerations for Introduction to Polymers and their classification focus on recyclability, energy use, and regulatory compliance. Life cycle analysis shows that energy-efficient processing reduces carbon footprint significantly. Compliance with environmental regulations is mandatory for all industrial operations. Recent advances in Introduction to Polymers and their classification include nanocomposite reinforcement and smart material integration. Industry 4.0 enables real-time process monitoring using IoT sensors and AI-based control. Bio-based alternatives are gaining traction as sustainable replacements for conventional materials. We have covered the complete fundamentals of Introduction to Polymers and their classification from principles to applications. Remember the key property values, process parameters, and design formulas from this lecture. Subscribe for more technical lectures like this one. That wraps up today's lecture. If this was helpful, please like, subscribe, and share with your classmate. Subscribe to CIPETHUB for more technical lectures.